moving on to the next tech talk. And it also kind of looks at the future, and we're talking about what is the trends that are happening, what is the pulse of wearables, is this reality, where is it going? So we're really excited, or I'm really excited to bring you David Schie, who's the CEO of Linear Dimensions, and his New Year's resolution is to bring bioimpedance to the masses. So let's give him a warm round of applause. Thank you.
Hello, everyone. Good to be here. David Schie from Linear Dimensions. So Linear Dimensions is well positioned to give you some feedback on the future of wearables. We're a vertically integrated company that does the sensors, the microchips, algorithms that work in real time without microchips, and then top-level software and apps. So we interface with a lot of the leading companies in the industry and see a lot of the new technologies. So some of you last year may have seen my talk, and we talked a little bit about the convergence of communications devices like cell phones with the wearable devices, and we talked about the first cell phones that came in a bag and how now they're these slick glass devices, but we can still leave them in places and drop them in the toilet and so forth, and how our kids will probably be asking us why we would carry a piece of glass around when we could have them in all sorts of different devices all over our body. And that's what the future brings and what we think is going to happen. And we'll talk about some of that technology today. So we start with some of the existing products and sensors. Most of what we're seeing now are motion-based. So we're seeing a lot of fitness devices, a little bit of the coaching and the diagnostics to some degree. We're doing some sharing and authentication, some gaming, some mental gaming, and some pattern matching devices. We're seeing Google Glass and so forth used in surgeries, and some medical devices starting to make their way in, more interestingly, to these wearable devices. But we're still sort of in the connected self 2.0 stage. The connected self 1.0 was really the accelerometers, the gyroscopes, the MEMS sensors that came along to produce those kind of devices. We're now in the stage where we're hearing people are taking their devices, throwing them in a drawer. After 6 months, they don't do enough for us. So we have to give them more value. We have to put in more sensors. We also have to make those sensors useful for them. And so we're seeing a lot more PPG, light-based devices to take heart rate. We're not seeing as much ECG yet. That's bioimpedance-based, but it's coming. UV light, blood oxygen, proximity, some of the respiration, some of the mapping and the compass techniques, and more of the remote DSP and analysis. Databases are coming online. EEG is very interesting. There's a lot that can be done with the brain and control concentration and so forth, and we're starting to see less Frankenstein-like devices and friendlier devices. But one of the fundamental problems we're still having is the battery life. And the battery lives are being killed by these optical sensors. So we believe the bioimpedance sensors are going to come quite far in the next while. The problem with both the contact and the non-contact bioimpedance is they're very sensitive to noise. They're very sensitive to motion. So you have to get a lot of algorithmic work going. You've got to mount them in specific ways, but even for getting heart rate on the wrist and so forth, IPG and other options are available at a tiny fraction of the optical solutions, and those solutions are coming along, and we believe those will start to displace the optical solutions. So you'll see a lot more of that, a lot more machine learning algorithms going into these devices capable of doing the work on the device, instead of burning all of the battery power, sending raw data at very high bit counts and trying to get all the motion artifacts out later. So there's a lot of activity in this area. Next CES, you'll probably see a whole lot more devices with the bioimpedance sensors and a whole lot less of the optical, silicon nitride, silver chloride, and some of the copper gold and mesh types. So the wearables and a lot of industries actually came along because of all these new sensors. So the MEMS sensors came along, they created these scooters to these wearables and so forth. So to see the future, looking at those devices can be very useful. So we've seen the MEMS sensors, and we've seen a whole bunch of motion sensors. And most of the devices today are taking advantage of all these motion sensors, and they're giving us interesting information about how many steps we take and so forth. And then we're starting to see the MEMS compasses come online and some of the GPS being put into it. The authentication is going to be a big thing in the coming years. The sensors are getting to the point where beyond fingerprint, we can use the heart, ECG, and other information to do authentication. Then the displays continue to improve. We're seeing a lot more VR-type displays, a lot more low-light displays, APD types, flexible displays, the contact lenses, the glasses. They will proliferate. On the RF side, we're seeing actual biasing of the power supplies in line with the data being sent, so PA biasing and so forth, which are extending the battery lifetimes for the RF, which is one of the bigger killers of the battery. We're seeing microfluidics, the new hydration sensors, the sensors that can actually pump the drugs or pump other things. We're seeing some new stem cell type sensors that can both read the information and be actuators. Microneedles, and then we're seeing for the first time some of the ultrasound Doppler come into our space, which will be very interesting because they can see the blood vessels, blood pressure, they can actually see the tendons move, so new gesture control methods. And then we still haven't seen much of the morphing materials, which we believe will be a huge boon in the future. People will just be amazed when their devices can change shape or keyboards can rise out of them. So last year I did some predictions, and I'll continue to do that. So we were talking about some of the new healthcare. There's a lot of changes in healthcare, and fundamentally what doctors do, or a big part of what they do, is pattern matching. You go in with a symptom, they're listening to acoustic patterns, electrical patterns, many other patterns, and trying to match those symptoms up to what you have. But you get a symptom, you make an appointment, you go in however much often, you talk to the guy, then you go for another test. It's inefficient and you don't catch things early. So we're seeing a lot of these devices for monitoring outside the physician, so we call it Borders Without Doctors, devices that can take all of your vitals, do a health interview, and let you go to the pharmacy and have a physical and so forth. Maybe send your data to the doctor, but between the motion, the ECG, the electrical, all the rest, we can get a lot more information earlier and get it to the doctor on a more continuous basis. So the AI physicians are going to be a big thing, especially the way healthcare is being paid for today. It'll reduce costs, and the regulatory agencies are one of the big hurdles there, but with some of the big names in the industry bringing out devices, we hope we can break through that. So if we've all been reading the reports about the hackers, I think we can all conclude that our data is not secure and that we have a big problem out there. We've seen Home Depot, Target, everyone and their brother losing our information. So as wearable devices, we have a unique ability to be the password. The information in our body is a great password. And if you're like me, all you can remember on multiple sites is your dog's name, Fido, and your birth date and stuff like that. So you use the same password 50 times, and you don't change it if you can avoid it. So what these devices can literally do is use your body, maybe not even turn it into a digital, leave it as an analog signal, a pattern, and keep it very secure or generate very secure passwords on your behalf. And so this can be done seamlessly with devices that you wear, like locks that you use, or mice, or garments, or watches. We think that's going to be a big trend over the next little while. The EEG has come a long way. We're seeing much nicer form factors. We're seeing very positive sides of things where you can control, help ADD, concentration, athletes. We're also seeing the negative side where there are people that are tracking employees because you can see if they're working, you can correlate that with their motion, with their other physiology, and you can actually measure people's performance based on the data that you can make and reward them. And we think insurance companies and businesses will take more use of that, call centers and so forth. The morphing materials, we talk a lot about this. Somebody at some point in time is just going to blow everyone away with devices that can morph. They're strained materials that can literally change shape. These devices can have keyboards rise out of them. They can train to a touchpad. They can just do amazing things. There's some electrostatic challenges, which I think is what's holding them back, the high voltage needed to move them. But at some point, we're just going to be amazed when we see these devices come out. We're going to see some systems thinking. So one of the issues in the industry is we have the chip guy who hands off to the embedded system guy who hands off to the algorithm guy. And none of them really work together that well. So we're sending enormous amounts of data at high bit rate for DSP, which just doesn't work for wearables and IoT. we're going to start to see many more chips with algorithm working together, removing the noise, for example, before it gets into the system, sending far less data through the RF, wasting less energy that way, and getting battery lives to be weeks or months instead of being just hours or days. So one of the issues that we have in tech is the moment you put a screen on something, it looks geeky. So there are new technologies like liquid crystal string or liquid crystal thread. You can literally sew displays. So new displays will be made and used, just showing little bits of data here and there that will sort of take the geek factor out of the equation. And then finally, one of the problems that we have and one of the advantages that we have is we're going to be giving enormous amounts of information about ourselves to all sorts of databases. And those databases are going to be used by marketers, and they're going to be used by insurance companies, and they're going to be used by government. And we've noticed recently, and over the last couple of years especially, that those are all leaky databases and things that need to be watched carefully. So as we create our wearables and as we give these great new opportunities to log data in real time and learn about ourselves and share the data, we need to use the same passwords and security of our body to protect the data so that we don't lose our privacy. Anyway, I'd be happy to take questions later at the booth, and I appreciate your time, and please enjoy the rest of the show. Thank you.